So using some applications of vectors, we're going to apply these to physics problems by splitting them into their horizontal and vertical components. So find the initial horizontal velocity and vertical velocity of a stone kicked with an initial velocity of 16 feet per second at an angle of 38 degrees with the ground. So, all right, we can make this into a right triangle. 16 feet per second is the initial velocity. That's going to be the hypotenuse of the right triangle. At an angle of 38 degrees with the ground, we need to solve for the, we'll call this Vx and Vy, the horizontal and vertical velocities. And so we can just use SOHCAHTOA, right? And so Vx is going to be the cosine, because that's the adjacent side and the hypotenuse. So cosine of 38 degrees is Vx over 16. Multiply both sides by 16. And Vx is 16 cosine 38, which is 12.6 feet per second. And then Vy is going to be the sine, because that's the opposite side. So sine of 38 is Vy over 16. And we multiply both sides by 16. And so we get that Vy is 16 sine 38, which is 9.9 feet per second. Piece of cake. The parametric equations for the path of a projectile. If a projectile is launched at an angle of theta with the horizontal with an initial velocity of magnitude v, the path of the projectile may be described by these equations where t is time and g is acceleration due to gravity. So you may recognize these from physics, right? So what we just did, right, the initial velocity for the x was magnitude v, right, which was 16, times the cosine of the angle, right? In the x direction, your acceleration is 0. So it's an object traveling horizontally is going to travel at that same velocity. So to get the position of that projectile in the x direction, you just multiply that initial velocity by t. And that's where you get this. You do the same thing with y. Y is the sine theta. And you multiply that by t. But you also have the acceleration due to gravity. And so this 1/2 gt squared is the acceleration due to gravity. And so that's going to give you the position of the projectile in the y direction. Suppose a professional football player kicks a football with an initial velocity of 29 yards per second and an angle 68 degrees to the horizontal. Suppose a kick returner catches the ball 5 seconds later. How far has the ball traveled horizontally, and what is the vertical height at that time? So 68 degrees, initial velocity of 29 yards per second, 5 seconds. So our theta is 68 degrees. Our initial velocity was 29 yards per second. 68 degrees velocity was 29 yards per second, and the time t was 5 seconds. So, how far has the ball traveled horizontally, and what is its vertical height at that time? So, our x is t magnitude v cosine theta. Our t is 5. The magnitude, this is technically the magnitude of vi, is 29, and our theta is 68 degrees. So 5 times 29 times cosine 68 is 54.3. Our velocity was in yards per second times seconds, so this is going to be an answer in yards. And then our vertical height, y, is t magnitude v sine theta minus 1/2 gt squared, which is going to be 5 times 29 times sine 68 minus 1/2 acceleration due to gravity, if we're talking about, is going to be 9.8 feet per second, or sorry, not 9.8 meters per second, 32 feet per second. So gravity is 32 feet per second. Our other answer is in yards, so if I want to change feet to yards, 3 feet in 1 yard. So that's going to be 32 over 3 for my gravity, and then my time was 5 squared. And so then I can put all this in my calculator. This is 5 times 29 times sine 68, which is 134.4, and 1/2 times 32 over 3 times 5 squared is 133.3. And that's going to be, when I subtract that, that's pretty easy subtraction, 1.1 yards. Just got to keep track of my units. Suppose the kick returner lets the ball hit the ground instead of catching it. What is the hang time, the elapsed time between the moment the ball is kicked and the time it hits the ground? So we are looking for t. We're looking for t when our y is equal to 0. Right? So if our y is equal to 0, this is, our v is still 29. Our sine theta, still sine 68, t, minus 1/2 times 32 over 3 times t squared. And we want to solve this for t. This is going to be a quadratic equation, and it's going to be an ugly one. 29 sine 68 is 26.9 t, and this is 32 over 6 is 5.3 t squared. And it's not that bad because we can factor this, right? Because we've got a t in both parts, we can factor this, which makes this actually not so bad. So factor out the t, and this is 26.9 minus 5.3t equal to 0. So either t equals 0, at time 0, the ball is on the ground. Makes sense. Or 26.9 minus 5.3t is equal to 0. And we can solve this by adding 5.3t to both sides. And it's 26.9 equals 5.3t, and then dividing by 5.3. So we're going to get 26.9 over 5.3, which is, when my calculator decides to cooperate, 5.07. So let's say 5.1 seconds. That's your hang time, right? So when it hits the ground, that means that your y equals 0. So set your parametric equation for y equal to 0 and solve for t. Plug in the stuff that you know, solve for t. And I come up with 5.1 seconds, thereabouts. Which makes sense because at 5 seconds, it was 1.1 yards above the ground. So it's going to be a little bit more than 5 seconds, but not a lot more than 5 seconds. Casey Clark led the Women's Pro Softball League in strikeouts in 1998, which just shows you how old this book is. Suppose she throws the ball at an angle of 5.2 degrees with the horizontal speed of 67 miles per hour. The distance from the pitcher's mound to home plate is 43 feet. If Casey releases the ball 2.7 feet above the ground, how far above the ground is the ball when it crosses home plate? So, right, so she's releasing the ball at a horizontal speed of 67 miles per hour. And she is releasing the ball 2.7 feet above the ground. So we want to add 2.7 to that vertical distance, right? She's starting up 2.7 feet instead of starting on the ground. And we have an angle of 5.2 here. The thing is that we know, the 67 is the initial velocity. I misread that as being the horizontal speed, but it's just the initial velocity. So exactly the same as before, right? So RVI, or the magnitude of RVI, is 67 miles per hour. We probably want to go ahead and convert that to feet. Probably feet per second would make more sense, because all of our other answers are in feet. So 67 miles in 1 hour. 1 hour is 60 minutes. 1 minute is 60 seconds. But we also want 1 mile to convert that to feet, and that's 5,280 feet. So 67 times 5,280 divided by 3,600 is going to give us an answer 98.3 feet per second. Which is a much better unit to use for this problem. So 98.3 feet per second is our initial velocity. Our angle theta is 5.2 degrees. The distance from the pitcher's mound to the home plate is 43 feet. We're going to use that to find the time, right? Because in the x direction, there's no acceleration. right? So x equals TV cosine theta. Our x is going to be 43 feet. We need to find the time that it takes the ball to travel 43 feet. So 43 feet is t. We're going to use that 98.3 feet per second times the cosine of 5.2. And so 98.3 times the cosine of 5.2 is 97.9. So 43 equals 97.9 t divided by 97.9. And this is going to be t equals 0.44 seconds. Imagine if we had done that in hours instead. That would be awful. So converting to feet per second was a good choice. So 0.44 seconds. Now what we want is how far above the ground. We're going to use that y equation. Y equals t v sine theta minus 1/2 gt squared. But we're going to add 2.7 because we're not starting on the ground. We're starting 2.7 feet above the ground. So adding 2.7 at the end. And we're going to use the t that we found in the first part. So this is 0.44 times 98.3 times sine of 5.2 minus 1/2. Our acceleration due to gravity, g, is 32 feet per second squared. So in the previous problem, we were doing things in yards. So we had to convert our gravity to yards per second squared. Here we're doing things in feet, so we can leave it as 32 feet per second squared times 0.44 squared plus 2.7, which is a lot, but this is why we have calculators. So 0.44 times 98.3 times sine of 5.2 is 3.92, and 16 times 0.44 squared is 3.10. That's a minus. Plus 2.7. So that's going to be 0.82 plus 2.7 is going to be 3.52 feet above the ground when it crosses home plate. And that's it. Wasn't that fun? That's it for section 8.7.